with that choice is very hard. If you have 50 toothpastes in front of you, making a choice becomes a lot harder. And even you may pick the same toothpaste, the emotional feeling that you have, whether or not you've made the right choice, makes you often feel sort of not that happy with the choice that you make, because you have a feeling that you might have made the wrong choice. Yeah, and we have this, and in a grocery store that's easy. In online world, we don't have 50 toothpaste, we have 2,000 toothpaste, or 10,000 toothpaste. So, the likelihood, if you have more choices, that it's harder for you to make a choice in the first place, and if you do make a choice, it's very likely that you may be unhappy with that choice, even though it's the perfect one. And so, personalization is one technology that helps you reduce those choices back to a set where it might actually help you make the right decision and feel good about that decision at the same time. And so all of that is driven by machine learning technology. Now, I'm going to show you a few how some of these things worked in the past. So if you think about email targeting, you want to send out these emails and make your customer aware that there is this great deal going on. In the past, this would look like some sort of SQL query, yeah? And you would say, no, it's not going to send it to all customers that had an order in the past 20 days. No, let's send it to customers that have bought a toy, or a helicopter, or a quadcopter, or let's go and do all this sort of refinement. That was a lot of work and never resulted in sort of the right approach. Yeah? What you want to do is actually, you want to take information from the past to drive the likelihood that customers will respond to your email. So what you do is you sort of take the data from the past about emails that you have sent out and which customers have actually responded to those emails, and then start building models about it. So it's all about this line that says, has the customer clicked this email when we send it to them? And so that's what we would call training data. Yeah? That's the data from the past. And then you make it, so you build models around the training, and so you use that model to sort of predict whether or not other customers will also click that email. And so what you then have, you have input data where these are the likely customers that you want to send your email to. And so you put that into the model, and then the output of the model is a prediction whether or not these new customers will actually also click this email. And so then you get a whole list of predictions. And in general, there's a prediction score, and whether or not you're going to assume that they're going to click this email, it's all about that score, whether you think it's going to be, the cutoff point will be 0.85, or whether it will be 0.5, or something like that. So what kind of things can these models do? Yeah, say, for example, they can try to detect whether an order might be fraudulent or not, which means that it's not necessarily that it is fraudulent, but this might be an order that you will give to investigators to figure out whether or not this actually is a fraudulent order. And that's what we call the binary classifier. Yeah, or whether the detection of gender, for example, trying to predict whether this is a female or a male. Yeah, or demand forecasting is something that is called regressions. Yeah, where it's not a binary kind of thing, but where you try to predict a number. Yeah, or try to figure out what categories a book belongs to in an automatic fashion. Yeah, or look at reviews and figure out whether they are abusive or not. And so you may have multiple of these classifiers working together and go into the email training model, and then that will give you the predictions. Now you have to figure out how good is your model. And what you do is you go through a validation phase. What you basically do is you take 75% of your data, use that as input data, and then you take 25% of that data and put it into your model and see what the reaction is. You already know what the outcome of this is going to be because this happened in the past. Yeah, and so basically you should take your test data, look at the evaluation results, and then figure out how accurate your model is. And then you use that to go back and use every 25% of your data every time to figure out how good your model is and whether or not you actually need to sort of either improve your data or improve the model that you're using. And then in the end you end up with a final model. And so often these things can be combinations. When you give a binary classifier that says the likelihood of this particular order being fraudulent or not, or whether it's in stock or not, and then use a regression model to get a sort of refinement on top of that. So why is this all suddenly so new? Why are we talking about this? Because this stuff is things that we've been doing for the past 20 years at Amazon already. It turns out that actually building these kind of models using machine learning has been really hard. It's really time consuming, there's many algorithms out there. And so there's a lack of expertise in there, there's many different technologies to choose from, and it's actually really hard to put it into production. And so at Amazon, within Amazon, given that we were so dependent on machine learning, internally we started to develop a machine learning service, such that our engineers no longer needed to do all the hard work around this, but actually have a service that they could use. And so using this service, we did an experiment. You know, in the past, to do this sort of a grouping an exercise for around your customers would take 2 months, and it would end up with sort of a 92% accuracy. With the machine learning service that we developed, a junior developer could get this done within 20 minutes. Yeah? And so moving all the heavy lifting around machine learning into the service, suddenly we saw an explosion of the use of machine learning within Amazon. We saw all sorts of new things happening. For example, item classification is something that we do completely automated these days. And so there's many of these new application areas purely because we had made a very simple service available for all engineers to use. You no longer need to be a machine learning expert to actually do machine learning. And so there's a huge opportunity there to use machine learning. And so what we've done is actually take this machine learning service and now make it available for everybody to use. And this is actually a really that simple service. It incorporates much of the classification engines that you've seen out there. It's robust, it's the same technology that Amazon uses internally, and you can make use of much of our cloud services combined with this. Often your data will be already living in the cloud or in the Amazon cloud, and as such integration into this will be very easy. There are lots of developer technologies around it. It's very powerful. It's not just the algorithms, it actually makes it very easy for you to have very large data sets of up to hundreds of gigabytes of data that you can use as your training data sets. Yeah? And again, there's some very cool stuff around this that you can automatically integrate machine learning into your application. But let me show you how this works. Much of these machine learning services is actually visual. Now we've decided to take a visual approach to doing this. It's a bit hard to see maybe for you here. This is a movie that should work. Apparently not. Try again. Yeah, okay. So what you do, it's hard to see on this particular screen here. What you do is you take your data set and you may start making decisions about how you want to classify this, what the size of your bins are supposed to be. Yeah, and then you do this visually, you start looking at whether or not you get the right level of granularity that you're looking for. And then once you're happy with your with sort of that approach, you're going to do a test run to see what the results of your bidding technique is. And then what you're going to do is you're actually going to take this data and some input data, some test data that you have, and go look at visually what the accuracy of your algorithm is, and what the false positives are, the false negatives, and all of these kind of things. So you can do this in a visual way. You can see what the output is of it. And so once you're happy with that, you actually make a decision to put this model into production. And with one click of a button, you can create a software component that you can use to integrate into your applications. So there's two ways. In the past, machine learning was all about batch predictions. So you would have a model, and then you would have to test your input data, and you would run that through the batch, and you would get all sorts of results back. But what we've done in this case, this software component that you've created with the Amazon Machine Learning Service, now can you put into production in real time. Yeah, that means that it has an API, you can call the API with data that you have here, you can get your score back. This, for example, you may have your application, you may create an order, you put the order in DynamoDB, some Lambda function has been triggered because you updated the row, that will go to your machine learning prediction API, and it will give you a fraudulent score back. These are things that you can now integrate into each and every one of your applications without having to run any servers or backends or things like that. So this is something that we've done such that we can now make it easy for everyone to integrate machine learning into their daily applications and make their applications smarter. There's a few more things I want to show that are actually this not only works on the numbers world, but it works on many different areas as well, such as image processing as well as video processing and things like that. Yeah, for example, this might be binary classification. Yeah? Asking, is this an urban or rural area? So that's an easy one maybe. Is this a healthy or unhealthy scan? But more difficult, of course, is which city is this? This happens to be Hong Kong. But most of these, you have multiple choices in this case. It's not just a binary classifier, it's a multi-classifier. Or what type of tumor is it that is in here? Or you just have an image, and you go, where is this object? Well, this is an easy one. But if this would be the image, it's a lot harder to figure out where the object is. But again, machine learning technologies can be used to actually do this kind of image detection. Or figure out what are the different components in this image. What is the grass, where's the car, things like that. Or find a different muscles group on this particular image. We also make use of machine learning in our warehouses in robotics. We make use of the Kiva robots, and we have about 15,000 of these robots running around in our warehouses. And all of the things that they do is moving goods around based on machine learning technologies. So there's many different application areas where you can make machine learning to make your application smarter. We run every year a challenge for universities or research labs to build new algorithms based on machine learning and by using robots. It's called the picking challenge. And so what you have in your warehouses is that you have all these goods stored in different bins, and you need to be able to pick the right objects from each bin. And so to do this completely automated, we challenge every year researchers around the world to come up with better algorithms, or using a standard set of robots to be able to pick the right goods in the right order and put them in the right baskets. This has actually turned out to be pretty hard, but there is a lot of research going on. All of this is again driven by machine learning. So with that, there's never been a better time to build really smart applications. There is no longer a barrier for you to actually start integrating machine learning into each and every one of the applications that you've built. Because now machine learning is just a software component that you can create for 4 or 5 visual steps. So with that, I would say go build smarter applications, and thank you for listening to this.